Assalamualaikum and good afternoon. We from Group 9. My name is Muhammad Ashraf Hakim and this is my member name Arif Syahmi, Cik Nurhasni and Nabila Atika. For the introduction is about induction motor. Induction motor is a synchronous motor in AC electric. Electric current on the rotor required to produce torque. To the torque created by electromagnetic induction from the rotating magnetic field. For this experiment project, we require to observe about torque versus speed and power versus speed, also involved with calculation. After that, we select the data based on the spec given. Then we require to use MATLAB software to program the coding for auto calculation for the induction motor and simulate. When receive the data, it will generate result on the graph with MATLAB. Next, about the methodology, this is the flow chart for our project. Initiate is defined by start, then we collect fact and requirement that need in this project. Proceed to begin scope development for start the work, then go to the project plan by make a structure work. After that, go to the quality control and independent verification and validation to check the calculation work and eliminate mistake. Then proceed to the testing code and then make a correction coding error on document new lesson learned. After that, simulate the code on the sign off. If the code programming error, go adjust the code and test run again. If the code success, to simulate, proceed to the project close. Next, I will pass to Cik Nur Hasni.
Assalamualaikum. My name is Cik Nur Hasni binti Cik Razali and I will explain about my part, which is procedure of modeling work. The first step of this procedure is we have to declare and save the parameters of the induction motor in the MATLAB coding. Second, we have to declare and save the values of all the resistance for R1 and R2 and also the values of all the impedances used for X1, X2 and XM. Third, we have to declare and save the values for the mechanical loss, coil loss and the miscellaneous loss.
Bismillahirrahmanirrahim. My name is Nabila Atika binti Badul Hisham and now I will be presenting about the result and discussion. Okay, in this experiment, we use MATLAB software to investigate and demonstrate the electric characteristic of induction motor. So firstly, we need to show the procedure of modeling work in MATLAB. So as you can see, firstly, we declared the rated voltage, number of poles and rated HP. The figure 1 is our MATLAB coding and figure 2 is our command window. As you can see, we declared all of the parameters for the induction motor. Okay, step number 2, for the resistors and impedance values, we also chose these values and then we declared it in the MATLAB coding. Figure 3 shows our MATLAB coding for declaration for each resistance and impedance. For figure 4 is the command window for the value of resistance and impedance. For step 3, those are the parameters for mechanical loss, core loss and miscellaneous loss. Figure 5 shows our MATLAB coding that we use to declare those losses. And figure 6 shows the command window for the losses of the induction motor. Okay, next is the processes in obtaining the torque, speed and power speed characteristics. Okay, firstly, to obtain this torque speed and power speed characteristic, we need to firstly obtain the N sync, V, phi and omega sync of the induction motor. So these are the formulas that we use for both manual and coding. In figure 7, that is the MATLAB coding that you can see the formulas that we declared in the coding. Figure 8 shows the MATLAB coding in command window. In figure 9, MATLAB coding for value of slip. So it is varied from 0 to 1 with interval of 0.01 slip. Okay, and then this is the formula for slip and M equals to 1 minus S and sync. Okay, next we need to know the Thevenin equivalent voltage and impedance of the circuit. So this is the Thevenin equivalent voltage and impedance circuit. As you can see, the following is the calculation, manual calculation that we get for voltage Thevenin, impedance Thevenin, resistance Thevenin, and reactance Thevenin. This is our manual calculation. Figure 11. This is the MATLAB coding for the Thevenin equivalent voltage, impedance Thevenin, and resistance Thevenin, and reactance Thevenin of the circuit. Figure 12 shows the command window with all of the formulas. Okay, next step. Based on the Thevenin equivalent voltage and impedance circuit, we can find the torque speed characteristics. So we need to determine the slip at pull-out torque as max, pull-out torque max, and the mechanical speed when the pull-out torque occur, Nm torque max. Figure 13 shows the MATLAB coding for the slip at pull-out torque, and mechanical speed when the pull-out torque occurs. Figure 14 shows the command window for these values and formulas. So now this is figure 15. Figure 15 shows the MATLAB coding for the current of I2, maximum air gap power, maximum converted power, output power, and input power. Okay, and for figure 16 is the command window for the values.
My name is Arif Shahmi, and we explain about the performance analysis made on the motor model. So basically, as we hear from the result and calculation presented by Nabila, so we can finally plot the torque speed characteristic of the induction motor. So basically, is in this figure 17 shows that the calculation which is using for loop in order to find the value based on the differences of value of S between 0 to 1 with interval of 0.01. So from here, we made the coding for the graph, and this graph that we have got from the simulation. So basically, based on the graph, as shown here, it says that the pull-out torque of the motor is 583.316 Newton meter, and the mechanical speed of the pull-out torque is 1,267.40 RPM. So same goes to when we need to find the power speed characteristic graph of the induction motor. So here, basically we need to find first the power air gap and converted power. So here is the formula that we need to input in the for loop, and then after we get the air gap power, we insert it into the converted power, and looping has started for the value of S from 0 to 1, and here is the coding for the graph, and this is the induction motor power speed graph. Based on the graph and the calculation have been made before, the power converted max is and the maximum power is 77,850 Newton meter, and the mechanical speed or the corresponding output power is 1,275 RPM. So basically, this is our overall coding for MATLAB, and here is the command window. And this is the graph, as we can see, made from the simulation. After that, we can find the efficiency. So from here is we can get the efficiency by dividing between P out and P input, and times by 100%. So basically we get efficiency by 65.01%. And this is the coding and its output. We can conclude that after the manual and software work, we obtain the result with the similar output by the theoretical calculation. So basically in this experiment and assignment, we get that electrical machines are important in our current technology because it's crucial to produce alternative energy strategy toward the future with more technologies being discovered to make the world better and more sustainable from pollution and less carbon emission. So basically, we can use MATLAB software to discover the simulation of the induction motor, and we can compare it to the manual calculation. So basically, we can improve our teammate and learning skill by using MATLAB simulation, and we need to use it to run for loop coding, and also we can get the output of the graph, torque speed, and also power speed. So that's all from our group. Thank you.